Hello everyone, welcome to AP Physics C, Practice FRQ Set 6 number 5. System of mass is arranged as shown in the diagram below. The system is initially held stationary and then released. So, initial velocity will equal 0. Ignoring any friction, find the following. Part A, which way left to right will the system move? So basically the question asking whether these masses will move or rotate this way, left, or this way, right. So, to make this easier, I'll say a positive force means going to the right, and a negative force means moving to the left. So, what are the forces that influence which way the system moves? Fg of 3, mass 3, Fg of mass 1, and Fg of mass 2. But you have to find the force that is parallel to the incline because that is the direction the system is moving, M2 is moving. So here would be Fgx of 2. Those are the three forces. And as you can see, Fgx2 and Fg3 are moving the system to the right, so we'll label that as positive, and Fg1 is moving the system to the left, so we'll make it negative. Alright. So, we'll find the net force of the system to determine which direction it's going. So, like I said before, the positive forces are Fg3 plus Fgx2, and the negative force is Fg1. Okay? We'll simplify that, expand it to m3g plus m2g of sine of the incline, which is 45 degrees, minus m1g. Okay, the mass of 3 is 5g plus 5g sine 45, m2 is also 5g, minus m1, which is 8g. Okay, multiply these together, we'll get 49 plus 49 sine 45 is 34.65, minus 8g is 78.4. Okay, and in the end, add them all together, and we'll get net force will equal 5.25 newtons. Alright, part B. What is the speed of M3 after it has traveled a total distance of 0.5 meters? Okay, so what we can use here is common form. Vf squared minus Vi squared equals 2a delta y. But what is a? We can find a. Let's go out to the side here. Net force equals mass times acceleration. So a will equal net force over m total, the total mass of the system, and we'll get net force is 5.25, and the mass total is the sum of all the masses, 8 kilograms plus 5 plus 5, which is 18, and then we'll end up getting 0.29 meters per second squared, and we'll plop that in. So the initial velocity is 0, so we end up getting Vf squared equals 2 times 0.29 times 0.5. Divide together, you get 0.29, and then square root, you get Vf equals 0.54 meters per second. Part C. What is the time to cover the first 0.5 meters? So to do this, I'll just use average acceleration. Acceleration equals change in velocity over change in time. And we'll isolate for time to get Vf minus Vi over A. Vi is 0, so we get Vf over A. Vf is 0.54 and A is 0.29, and we'll get 1.86 seconds. Okay. Part D. Using ratio, find the time it takes for M3 to travel an additional 0.5 meters. So from 0.5 to 1 meters. So to do that, I will find the time it takes to go from 0 and 0.5 and from 0 to 1. I'll go from 0 to 1 because it's easier since VI will equal 0 then. So let's put this into 2 because TI and TF, TI being 0 to 0.5 and TF being 0 to 1. Actually, it'll be easier to call it T1 and T2 because it's not really initial and final. Okay. So we will use the position function. Yeah, equals VIT plus 1/2 AT squared. This will be T1. So we're going to be isolating for T1. VI is 0, so VIT1 is 0. Okay, you divide both sides by 1/2 A and you get 2 delta Y over A equals T squared. T1 squared. And then you screw to get T1 equals 2 delta Y over A. Now for T2. It's going double the distance as T1. So we'll put 2 delta Y equals VIT2 plus 1/2 AT2 squared. Once again, VI is 0. Divide both sides by 1/2 A. We have 4 delta Y over A. That's T2. And then 4 delta Y A square root equals T2. Okay, so next I will set up a proportion of T1 and T2. So T1 over square root of 2 delta Y over A equals T2 over square root of 4 delta Y over A. Okay, then I'll cross multiply to get T1 4 delta Y over A equals T2 2 delta Y over A. Okay, then we cross out the same things, the things they both have in common. I mean, I'm getting T1 rad 4 equals T2 rad 2. Divide both sides by rad 2, and we'll get T1 rad 2 equals T2. So T2 is rad 2 times greater than T1. And we know what T1 is 1.86. 1.86 times rad 2 equals T2, which means T2 will equal 2.63 seconds. But the question is asking what's the time from 0.5 to 1. So what we'll do is take T2 and minus T1 to get 2.63 minus 1.86, which will give us 0.77 seconds as our time. Okay. So part E. Part E is asking us to use ratio again, but instead to find the speed of mass 3 after it has traveled a total distance of 1 meter. Okay. So like before, we'll split this into VF1 and VF2, and we will use the average acceleration function. So A equals VF1 minus VI over T1. And over here we use A equals VF2 minus VI over T2. Okay, so we will isolate for VF. It should be VF1 equals AT1 plus VI. We can cross out I. And for VF2 equals AT2 plus VI, and we'll cross that out too because it's 0. What we can do now is substitute T2 with T1 rad 2 to get the same variables on both sides. And then like before, we'll set up proportions. VF1 over AT1 equals VF2 over AT1 rad 2. Cross multiply. VF1 AT1 rad 2 equals VF2 AT1. Okay, cross out A and T1. And then we're left with VF1 rad 2 equals VF2. So like time, velocity 2 is rad 2 times greater than velocity 1. And VF1 is 0.54 times rad 2, which means VF2 will equal 0.76 meters per second. Okay. Part F. What is the acceleration of M2? So, the acceleration of M2 is equal to the acceleration of the system, because acceleration is the same for all of the masses throughout the system, and A of the system is 0.29 meters per second squared. Easy question. Part G. Calculate the tension in the string connecting M1 and M2. So it's this string here, we call it T, and T is pulling M2 downwards and M1 upwards at the same time. So we have to choose which block we want to use for our Newton's second law equation, and we'll use M1. So net force equals we use M1, so M1A. And the two forces acting on M1 is T pulling it up and FG pulling it down. So since T is pulling it to the right, we'll label that as positive. T minus FG1 equals M1 equals 8A. Okay? So I say for T equals FG1 plus 8A. FG equals M1G, or 8G plus 8A equals T. Okay. Then we'll simplify that, and we'll get T equals 78.4 plus 8 times 0.29. Add them all together, and we'll get tension will equal 80.72 newtons. Okay. Lastly, part H. Find the coefficient of friction along the surface. Basically saying we'll add friction along the incline in order to keep the system stationary. Okay. So, part H, net force equals MA. But to keep the system stationary, acceleration will now equal 0. So, there will now be 4 forces. The 3 forces we labeled before. FG3 plus FGX2 minus FG1. But now there will also be friction acting against the system. 0. So, back in part A, we found out these 3 forces equal 5.25 newtons, which these are just Fk. Move Fk to the other side, we get 5.25 equals Fk. So, Fk equals to coefficient of friction mu times M2G, M2 because that is the mass on the incline, and since it's on an incline of 45 degrees, it's at cosine of 45, because f of n, force of normal, equals FGY, which is equal to M2G cosine 45. Okay. Mu M2 is 5, G cosine 45. And then we'll simplify that to get 31.82 mu equals 5.25. And divide 31.82 to both sides, and we get mu equals 0.16. Okay, that is it. I'll see you in question 6.